In this lesson, you'll learn how to solve quadratic equations by using the square root property. How can you find the time it takes an accelerating race car to reach the finish line? Under a yellow caution flag, race car drivers slow to a speed of 60 miles per hour. When the green flag is waved, the drivers can increase their speed. Suppose the driver of one car is 500 feet from the finish line. If the driver accelerates at a constant rate of 8 feet per second squared, the equation t squared plus 22t plus 121 equals 246 represents the time t it takes the driver to reach this line. To solve this equation, you can use the square root property. To be that they gave us a quadratic that was a perfect square on the left, so now I can take the square root of both sides. I've got t plus 11 equals plus or minus square root of 246, which is about 7. So t equals negative 11 plus or minus 15.7. Negative 11 plus 15.7 is 4.7. Negative 11 minus 15.7 doesn't make sense in this situation because we cannot travel backwards in time. You've solved equations like x squared minus 25 equals 0 by factoring. You can also use the square root property to solve such an equation. This method is useful with equations like the one above that describes the race car's speed. In this case, the quadratic equation contains a perfect trinomial set equal to a constant. For any real number n, if x squared equals n, then x equals plus or minus the square root of n. Solve x squared plus 4x plus 49 equals 64 by using the square root property. We are happy to note that the left side is a perfect square trinomial, and so is 64. So when we take the square root of both sides, I have x plus 7 equals plus or minus 8. Subtract 7 from both sides, I have negative 7 plus or minus 8. Negative 7 plus 8 is 1. Negative 7 minus 8 is negative 15. 1 squared is, of course, 1, plus 14 is 15, plus 49 is 64. And negative 15 times negative 15 is positive 225. 14 times negative 15 is negative 210. So that's 15 again, plus 49 is once again 64. So our check step works. And our two answers are x equals 1 and x equals negative 15. Once again, the left side is a perfect square, x minus 5, and unfortunately 12 is not. So when I go to take the square root of both sides, square root of x minus 5 squared is just x minus 5. Square root of 12, well, we can simplify it to 2 square root of 3. And then I'm going to add 5 to both sides, left off my plus or minus. So I've got x equals 5 plus or minus 2 square root of 3. That would be the exact answer. A lot of times they want a decimal rounded to the nearest tenth. So if we do 5 plus 2 square root of 3 and change it to a decimal, I get 8.464, so to the nearest tenth would be 0.5. And 5 minus 2 square root of 3 is about 1.5. The default setting in GeoGebra was set to go to the nearest hundredths place, but still with rounding I would get my x value to be 1.5 and 8.5. The exact answer, of course, was that first one where it was 5 plus or minus 2 square root of 3. We use the square root property by undoing and taking the square root of each side. Since we don't have a summary statement, we're not doing the whole lesson, I thought I'd end with going back to why the perfect square works. So I'm going to take x plus 11 times x plus 11, and we FOIL it out, and we have x squared plus 11x plus 11x again plus 121. So you can tell it's a perfect square because the first term is squared, The two middle terms, when we add those together, we get a double. If we divide that double by 2, we get one of those, and we can square it to get the last term. So this is always a plus here.